All right, everybody. We are going to start with today's lesson, which we're going to be learning how to deal with a two-proportion sample mean test and also learn how to construct confidence intervals from that. So again, before we get started, always want to try to think as we're adding these new significance tests, these new confidence intervals, how they're related to what we've already gone through in class, because then it's not about you learning something brand new, everything's brand new for the first time. It's more of you just adding something to adding some new concepts to something that you already know. So just keep that in mind as we're going through today's lesson. But we'll be going through some great formulas and some great practice problems, helping us understand how to compare two sample means. All right. So this first video is we're just gonna talk about the main formulas that we're going to use for these two sample mean tests. And like you probably found out last lesson, going through all the formulas is kind of hard to conceptualize. So if you're not 100% getting these formulas right away, that's fine. Once we start doing practice problems, they'll start to make a lot more sense. So when we're dealing with a two sample mean test, basically the way that we come up with our final mean is we subtract the two different means. So if we're dealing with the population, we subtract the mean from the population 1 minus mean from population 2. If we're dealing with a sample mean, we do sample mean 1 minus sample mean 2. Pretty straightforward, just like we were doing with our two sample proportion from last class. Now we do have a new formula right here that we are going to be using brand new. But again, as you're trying to memorize these formulas, think about how they're similar to what we've already gone through. If we think about back to our single sample mean test, our formula that we used for that was the standard deviation over the square roots of the sample size. So that was for one sample mean right here. And you can see how it's very similar to what this new formula is. So basically what it is, you're going to take your standard deviation squared divided by the sample size. And that's all from first sample number 1. And then we do the same thing, the sample number 2, we add them together, and then we take the square root of both of those. So that's how we're going to go about and use this standard deviation formula. So as we're going through and now looking at our formulas for our significance test and confidence intervals, basically we're using this standard deviation formula and essentially plugging it in to the bottom of our significance test, because remember that is where we put our standard deviation, and then we are plugging it also in to that last part of the confidence interval, because that's where it goes in our standard confidence interval formula. So again, if you try to think about these general templates for a significance test and a confidence interval, and then we're just putting in the new standard deviations, the new means, new different proportions for all these different tests, it becomes a lot easier to memorize and be able to do these problems. So we first look at these significance test formula. We're going to take the difference between our two different samples from 1 and 2, and then we're going to subtract that by what we expect the difference between to be between the other two, the samples from the population. So essentially, most of the time this is going to be 0 because we're going to assume that there's not a difference. And we're going to be testing to see if there is a difference, whether it's greater than, whether it's less than, or if it's not equal to. So we're going to be testing against if there is no difference most of the time. So this number is going to be essentially 0 almost all the time. So keep that in mind. Then, again, we divide by our new standard deviation formula. Our confidence intervals very similar as well. So we take a difference between our two different proportions that are listed right here. we used our critical t-score. Now there's something to make a note of here. I got this written down right next to this. Is that when we're doing our critical t-score, there's a couple different ways that you could plug in your degrees of freedom. The way that we're going to do it is we're going to take the smallest degrees of freedom between our two different sample sizes. So sometimes your sample sizes between sample 1 and sample 2 are going to be the same values, which it won't really matter. But if you have two different sample sizes, let's say sample size 1 was 10, the sample size 2 was 30, you're going to take the smallest sample size, then subtract that 1 to get the degrees of freedom. So if I had sample size 10 and sample size 30, the degrees of freedom that I would use is 9 because I take the smallest sample size minus 1. And I would plug that into inverse t to get my critical t-score. And again, we use the same standard deviation formula that we used in our significance test to come up with our standard deviation, which remember is on a confidence interval is also called the standard error. So this part of the formula, everything after the critical t-score, that's what we call our standard error. All right, so that is the formulas that we're going to be using today. And now we're going to spend the rest of the class just putting those to practice problems so we get practice using these in context of some examples.